Good morning or good afternoon, everyone, and welcome to this new series of webinars from the JavaCard Forum. Today's topic is a presentation from Klaus Dietze on the recommended 5G SIM. As we know, JavaCard has been very successful since nearly 25 years with billions of devices deployed. And a large part of this is coming from the subscriber identity module or SIM. As 5G is rolling out around the world since 3GPP release 15 and release 16 and now release 17 is in the work, JavaCard still continues to provide valuable features for the security of the network. Klaus will present us the new challenges of the 5G use cases and the Trusted Connectivity Alliance recommended SIM card to meet those challenges. Klaus Dietze is chairman of the Trusted Connectivity Alliance, as well as Senior Director of Global Standardization at G+D Mobile Security, where he's defining and driving the strategic standardization activities. Klaus has an extensive experience in smart cards and especially headed embedded development for mobile device solutions and software security, and later on the innovation department within the R&D organization. In terms of logistics, we will answer your question at the end of the presentation. You can enter them in the chat box during the presentation, or you can wait also until the end of the presentation. We will unmute the microphone. Please note also that you will receive a link to the webinar recording as well as the material by email shortly after the presentation. Without any other delay, Klaus, please, the desk is yours.
Yeah, thank you very much, Jean-Daniel, for this kind introduction and of course also for the opportunity to share some of the results of the TCA work within this JavaCard Forum webinar series and also within your JavaCard Forum community. Very much appreciated. Yeah, dear ladies, gentlemen, good morning for most of you, I guess, but also good afternoon. A warm welcome from my side to this webinar of the Trusted Connectivity Alliance on the recommended 5G SIM. The contents that I'm going to present to you today is based on a document that the Trusted Connectivity Alliance 5G Working Group has created. That is a group of subject matter experts from our membership, and the document that they have created is called Trusted Connectivity Alliance Recommended 5G SIM, a definition. That means that we have actually defined what we understand as being the recommended 5G SIM, and I'm very happy to present to you the key findings of that document today. The paper that we have created was published earlier this year and is highlighting and explaining all new SIM features that 3GPP has introduced in release 16, and it is based upon a first release of the same document that we have already published back in November 2018. And that paper back then covered all the new SIM features that have been introduced in release 15. And potentially when release 17 is bringing some new features, we are going to update the document again. So I hope you'll find the session educating and interesting. But before we start diving into the subject, I would like to give you a very brief introduction into the TCA itself for the ones who may not know us very well. The Trusted Connectivity Alliance, or TCA, is a global non-profit industry association, and our mission is to enable trust in a connected future. And with 5G, the IoT, connected cars, and all the trends that we are currently seeing, we also see a strong need to provide solutions for our society that offer trusted connectivity, that protect our assets, and that, of course, improve user privacy. And our members that I will show to you on the next slide are all leaders within what we call the global TRA ecosystem. And we have decided to use the term temporary resistant element, or just TRE, when we transformed from the SIM Alliance that we have been called previously to become the TCA. And that shows actually that we are using this term actually to cover all the different types of technologies, not only SIM, eSIM, iSIM, but all the different types of technologies and form factors that we are considering within our work. I'm not going to read out the definition there, but it's given on the slide for your convenience. As you can see on that slide, all the big players are actually part of our association. I'm also very happy to say that we are seeing growing interest in our association, driven by the new activities that we are pursuing, and that we also recently welcomed a new member with Oasis Smart SIM. So I'm very happy to announce that. And as you can see, we are also offering different types of membership levels. So if you are interested in joining or learning more about the TCA, please feel free to reach out to myself or check out on the TCA website. So what are we actually doing as Trusted Connectivity Alliance? And this is the last slide that I'm going to present introducing the TCA. Well, what we do is we work together, first of all, to drive innovation and the evolution of the TRE and its ecosystem. We promote the benefits of the TREs also in various market segments and verticals, automotive, for instance, but also others. And we also support standardization activities in other organizations, for instance, GSMA, you can see it listed there with IoT Safe, or also the interoperable profile specifications. And we are creating our own technical specifications and deliverables to further develop and enhance our ecosystem. We also put some focus on supporting the evolution of cellular connectivity in general, and in particular around 5G and IoT. A few words on the strategic initiatives, our key topics that we have dealt with this year and that we are also continuing to address in the coming year. First one is eSIM, of course, and our aim is to further improve eSIM interoperability and to also expand the benefits of using eSIM to IoT use cases and other verticals. And IoT, well, that's a big topic, not only for the TCA, but our opinion and our take on this one is we think the SIM is a TRE that is sitting in each connected device, and therefore it is the ideal root of trust that we can leverage for security topics, in particular also for the IoT. And this webinar is also part of our 5G SIM evolution initiative, where we are enhancing the SIM capabilities for 5G. And we are also here to educate the ecosystem on the benefits of using the 5G SIM. And it also includes highlighting the importance of a feature which is called subscriber privacy. I will come to that later as well. TCA also focus on integrated SIM technologies, where we also recently published a first paper, which is explaining the drivers behind integrated SIM functionality, where the approach is with regards to standardization, what are use cases and benefits of that type of technology. You can find that also on our website, and watch out, there will be a new version, a bit more technical paper that we are currently working on and about to release in due course. And last but not least, we are also monitoring the overall TRE market. We are doing publications on market evolution and developments in various segments, such as, for instance, traditional UICC, but also eSIM and 5G. You can find some indications there also on our website. And this is not only like the analysts are doing that based on forecasting, but this is also based on actual shipment data provided by our membership. And just to give you an indication on the usage also of Java card in the SIM market, we are also, let's say, reporting and measuring the market share of Java card in the SIM space. And just to give you an indication, in 2020, the market share of Java card was around 80%. And it is impressive to note, and this is also driven, I would say, by eSIM and 5G and those high-end new use cases, that compared to the previous 2 years, this market share is continuously increasing year by year. So let's now jump into the actual topic of this webinar, the recommended 5G SIM. To give you a little background, let me start with some basic statements to introduce the topic to you. So first of all, obvious statement is that the SIM and the eSIM are still the only platform that can be used to access a 5G network in a standardized way. And as stated at the beginning of this webinar already, we have published a first version of this document, Recommended 5G SIM, back in November 2018. And that document outlined various technical features that have been introduced to the SIM technology to address, in particular, the challenges that the MNOs were facing when they were migrating from a 4G to a 5G network. So saying, while release 15, or also called 5G phase 1, actually laid the foundation for a migration and laid the foundation for the 5G architecture and all the basic security, let's say. With release 16, or now 5G phase 2, this release was actually dedicated to really then enable the new use cases and to add many new features. And the paper that we have created in 2018 was now actually enhanced to include those new use cases and those new features that have been introduced in 5G phase 2 or release 16. When 5G was introduced, I guess everyone is aware of that. The 5G main use cases, you can see them here briefly listed on that slide. They were around connected vehicles, enhanced mobile broadband, massive IoT, critical communication. So everything which required high reliability, low latency, high bandwidth, and all these kind of characteristics. And as I've also briefly mentioned before, we are monitoring the TRE market, and our TCA member data showed that the year 2020 marked the first year of widespread 5G SIM deployments, recommended 5G SIM deployments. And what we can also see and what we can also expect is that the deployment of this type of SIM card is growing significantly this year, and will also grow significantly over the coming years with the let's say, ongoing deployment of 5G. So there is definitely some momentum around this technology and around the TCA recommended 5G SIM. And by the way, at TCA, we are not tracking the market share of Java Card in this particular 5G segment. However, if you personally ask me, I would estimate the market share of Java Card for this type of product to be de facto 100%. I cannot imagine that those high-end products are not leveraging the capabilities of Java Card. And I will give you one or two examples where Java Card is in particular beneficial also for 5G. Also, I'd like to mention that if I'm talking about the recommended 5G SIM here, I'm also including eSIM into this. That means that also the eSIM, of course, can be 5G enabled. There is also an interoperable profile specification version 2.3 and beyond, which is including 5G features into the profile for specification for eSIMs. And also in eSIM, even though Java Card is not really mandatory, the market share of Java Card is around 100%. That's don't cite me on this one, but that is what I would imagine. One more slide before we actually jump into the features. This slide shows a couple of things. First of all, indicated also by the arrows, there is some evolution of the SIM technology in general. It's evolving in the same way as also the network is evolving. The second thing that we want to show here, that there is also further evolution from release 15 to release 16. So that's indicated by that longer arrow. And this is actually the key message of that slide. The recommended 5G SIM is fully backwards compatible. So the release 16 version is fully backwards compatible with the release 15 5G SIM version. And the paper that we have issued provides a comprehensive overview of the feature set of the 5G SIM for both releases. So it contains both the release 15 as well as release 16 features. It's structured in a tabled format so that you can easily see which of the features is present in which of the two releases. Let's now jump into the topics. In this presentation, I will focusing on those listed new or also enhanced features. First one is private networks. They are also called non-public networks by 3GPP in their specifications. The next one is enhanced subscriber privacy, where also JavaCard is bringing some particular benefits. And this feature has been introduced as one of the key security features already in release 15 with the subscriber privacy protection. But here I'll do a short recap on the feature itself and also focus a little bit on the enhancements that have been done in release 16. Then we have Cellular V2 Everything Communication. And we also have improved mobile experience. And within this category, some more features are actually covered that I'll explain. The first one is enhanced steering of roaming. Then I will jump into network slicing, trusted non-3GPP access, and finally also multi-device and multi-identity. A short slide on this one. For the structure, how I'll present that, I'll first analyze and the background and the motivation and also the benefits and opportunities of the feature itself. And then I'll explain what the 5G SIM, the 5G recommended SIM actually does in order to leverage those benefits. And I've also included some information on how the feature is realized technically and what need to be considered when you're developing a 5G SIM profile. Let's start with a very interesting and personally I find also very promising new feature, private network access. 5G is driving rapid growth of private network deployments. And just to give you an impression on the take-up of this technology, I just before this webinar, I checked the website of the German Bundesnetzagentur, and let me check the English term, which is the Federal Network Agency for Electricity, Gas, Telecommunications, Post and Railway in Germany. And that is the authority in charge of granting actually licenses for private networks. I found that within the 3.7 and 3.8 gigahertz range, a total number of 169 licenses were granted per November 15th only in Germany. So if you compare that to the number of public networks, you can already estimate the overall potential. And the topic just started, right? And if you then look at the list of entities who have been granted such a license, we can also see that they are coming from very, very different market segments. For instance, you find some universities there that are potentially interested in campus use cases. You find players that are driving Industry 4.0 or factory automation, and you find many, many more. So that shows already that private networks are really a great business opportunity for all the different stakeholders in that ecosystem, ranging from equipment makers, private network providers, but also, of course, for mobile network operators. And they can, for example, dedicate a part of their 5G public network to cover for this new market request. And they can do that by using network slicing, for instance. And I will come back to network slicing later on. But how does now the recommended 5G SIM help here? First, let's point also something which is potentially obvious, but let's point out that the 5G SIM delivers exactly the same trusted connectivity and privacy user experience in private networks as it also does for public networks. So it simply ensures a seamless user experience for all stakeholders involved. Nothing changes, no new things have to be learned just because of that. And it also prevents fragmentation of device management solution. A device that is used in public networks can be managed in the same way as a device that is used in non-public networks. And that holds for both the device management itself, but also in particular for the management of subscription. And if you then combine that with eSIM technology, then you further have the advantage that subscription management can also be done fully digitalized, which in the enterprise network space is really a big advantage, I would say, right? By using the technical capabilities of the 5G SIM that I have listed there in this box to the right bottom, which is called technical features, The SIM also ensures support of different types of private networks. In 3GPP, we distinguish between standalone private networks or standalone non-public networks, and we also have private networks that are a part of a public network, which is called in 3GPP public network integrated non-public network. And regarding the technical features, potentially everyone is aware, but I'm just mentioning briefly. Each SIM has a service table, and this service table is indicating to the device which services the SIM actually supports. They are all numbered, and they are all specified in the USIM specification TS 31102. And in order to support now private networks, a new service 130 was introduced together with a couple of elementary files. And if you're now accessing a network, you of course need a subscriber identity. We know that all as the IMSI. And with this new service, the 5G SIM is enabled to also allow to access a networks that is using additional types of subscriber permanent identifiers. We also call them SUPIs, that have a different format than the IMSI. You need to know that the network somehow dictates which format of the subscriber identity can be used to actually access to it. And if the networks allows using the regular IMSI that we already know from previous releases, then nothing changes for the device, and the device can use also the regular USIM application to authenticate to the network. However, if the network expects a non-IMSI type SUPI, then the device will need to use a dedicated 5G SIM application that is capable of accessing a standalone private network using a non-IMSI type SUPI. And for this purpose, and in order to keep backwards compatibility with existing deployments, a new and dedicated application identifier has been defined for this dedicated USIM, and this application identifier was also registered at ETSI. Going to the next feature, which is actually not completely new in release 16, it's enhanced subscriber privacy. The first version of that feature was already supported and introduced in release 15. Let's do a short recap on the problem and the feature itself. You are probably aware that in previous generations, the IMSI was not encrypted. Therefore, by using so-called IMSI catches, you could actually retrieve the IMSI from the air interface, as the IMSI itself was not protected when it was used to connect to the network for the first time. And that allowed attackers to monitor the subscribers' locations, also intercept calls and SMSs. And yeah, please note that getting hold of such IMSI caches is not really a matter of spending huge amounts of money. They can be purchased quite easily on some strange websites as well. Of course, this security gap was identified, and it was addressed with the first release of 5G, release 15. And this feature then introduced the possibility for network operators to encrypt the IMSI before it is sent over the air. And this encryption could either be done in the SIM or in the device, and it's using elliptic curve cryptography, so traditional PKI encryption scheme. And by using this feature, the MNO, as I mentioned, is now able to protect the most prominent personal data that is actually involved in mobile communications, the identity of the subscriber. And the release 15 feature, what it did, it actually only covered the identifier that had the format being the IMSI. And with release 16, the feature was now also enhanced to cover non-IMSI type credentials, as we've just introduced on the previous slide. And how does now the recommended 5G SIM support this subscriber privacy? As I mentioned, the encryption of the SUPI, so the SUKI calculation, the subscriber concealed identifier calculation, can be done also within the SIM. And for this purpose, the SIM has introduced a new command, which is called the get identity command. And that command allows the device to ask the 5G SIM to actually compute this SUKI, this encrypted SUPI value, and send that encrypted value already back to the device. And by doing this, the device does not need to do the encryption itself. And all the security sensitive information is completely handled and remains completely within the trusted SIM. And in addition to that command, a couple of new services have been introduced to indicate those capabilities to the device. And of course, some files also have been defined. And with those new capabilities, the 5G SIM actually enables the MNO also to directly configure all the information that is needed to do the private subscriber identifier and the protection within the SIM, and the full configuration is under the direct control of the network operator. And of course, that feature can not only be used in public networks, but it can also be used by operators that are operating a private network. And what we also think as TCA is that if you do this calculation in the 5G SIM, we are also reducing risks of interoperability issues that you could potentially experience if you're doing that all in the diverse device ecosystem and landscape that you find out there. Let me highlight one thing in particular of interest here for this audience in conjunction with Java Card. So there is also an API that has been introduced, which allows operators to do the calculation of the SUKI within an interoperable Java Card applet. So that could in particular be interesting in case the network operator wants to either define its own protection scheme for whatever reason, security or whatsoever, for the SUKI calculation, or in case future protection schemes that are not defined by 3GPP when the product is launched, in case such new schemes need to be added to the recommended 5G SIM. Then, of course, doing that in an applet provides flexibility with regards to the lifecycle management. A short advertisement here as well. If you want to learn more about subscriber privacy and the benefits of using the 5G SIM over the implementation in the device, then please also check out the TCA white paper that we have created on that on our website. Let's go to Cellular V2X. That's also something important in 5G, in particular now as we have low latency and high reliability. This is enabling, of course, further deployments of V2X use cases, of course. And if we have a look at the opportunities I already mentioned, that with those new capabilities, those features really allow the network operators to deploy services that are based on the 5G connectivity and its capabilities. And the use cases that we see as an example, right, includes road safety, traffic management, traffic efficiency, but also infotainment and business use cases as well. The recommended 5G SIM helps here. Again, it was extended, so new V2X services indicating that the 5G SIM capabilities to the device are introduced, and they store the policy configurations in the USIM, and in conjunction with the services as such, also required elementary files have been defined and specified. So those services and files enable an efficient V2X configuration within the recommended 5G SIM. That means that certain parameters can now be configured also under the control of the network operator, and a variety of information such as expiration date, validity of parameters, a list of PLMNs, and many more enable a couple of configurations that are possible there. And configuring again the information into the recommended 5G SIM helps, of course, also avoiding market fragmentation across all the different terminals and car makers that are out there in the field, and ensures a consistent V2X functionality across all these different platforms. And it is important to mention that those configuration parameters could be handled within the device or within the SIM. However, if they are present in the SIM, then they also take precedence over those that are pre-configured in the terminal. And that is quite an important feature here. The next feature I'd like to explain is 5G roaming. It should be noted that in traditional steering of roaming solutions, the file system that is responsible to store the preferred network lists on the SIM was actually updated and managed over SMS or HTTPS. Those mechanisms work fine, however, are sometimes showing some technical limitations with regards to reliability. So it could happen that the new lists do not arrive on the SIM. And if that happens, it means that steering of roaming and its support in the SIM is of course an issue. Yeah, and the feature as such is not really new. However, with the introduction of now a standardized mechanism that was actually covered in a separate release 16 specification, the aim was to become it more stable and more reliable compared to previous releases. And why is this an opportunity? Well, roaming fees still are, and this will remain for quite some while, even though it's not really an issue in Europe anymore. But they remain an important revenue generator for network operators. And on the contrary, in case the feature does not work efficiently, this of course may also generate some loss of revenue for the home network operator. And it's of course also an opportunity because it's crucial for an optimized user experience that roaming policies are applied reliably. And how does the recommended 5G SIM help here? As mentioned, we do have traditional SIM-based steering solutions where the preferred PLMN list is transported over an independent OTA channel. I mentioned SMS, for example. With this new standard, the PLMN list is now coupled with a signaling registration, and that means that the OTA server is fully interconnected to the 5G core network functions. And by this, it can be assumed that the PLMN lists achieve a 100% success rate for the delivery of those lists to the SIM. And this reliability is the major benefit of that standardized solution. And it's with this new feature, the 5G SIM enables new steering of roaming services in 5G standalone networks. So that feature is available in 5G standalone networks. The MNO PLMN preferences in roaming situation are updated over the control plane, as I mentioned, to remove all the technical drawbacks that I've also mentioned. But at the same time, we of course make sure that confidentiality and integrity remains guaranteed. And we all know that such roaming agreements are, of course, very sensitive business agreements, and therefore it's important to ensure integrity and confidentiality there as well. And in case you want to have steering of roaming in a non-standalone 5G network, then of course you can still use the traditional mechanism using SMS for the update of the PLMN lists. When I was talking about the private networks in the beginning, we were already touching briefly on network slicing. And with network slicing, a network operator is actually able to create a set of logical networks on top of a shared network infrastructure. That is really a major breakthrough, I would say. That enables the network operators to meet the demands of very different use cases and the requirements of that. And it enables also the network operators to create logical networks or slices, right, that are very flexible and that are really designed to serve a defined business case. And this creates a lot of revenue opportunities and cost efficiencies for network operators compared to previous releases. And in order to also leverage those benefits, it's very important that the device is pre-configured with all the correct slicing information so that customers can benefit from an optimized user experience as well when they are switching on the phone, and it's already pre-configured with all the different slicing information they need for the various services. So for the recommended 5G SIM to support this feature, the new USIM service was introduced again, and also a new elementary file was defined. And those capabilities can now be used by the network operators to ensure that the end user devices are actually, as I said, really well configured already when they switch it on for the very first time. And also through those mechanisms, the recommended SIM provides a standardized and cost-effective solution to store pre-configured settings such as a data network name or single network slice selection assistant information. There are many, many more such parameters that could be stored and configured. What is also new is that now on the recommended 5G SIM, a BERTLV file system is available, and that is allowing to store large amounts of data, which is actually needed to also store all these routing information. So there is something called user equipment route selection policies, and those policies are quite large, and therefore a new file system was needed to actually store all those policy information. And in addition to all these configuration support offered by the recommended 5G SIM, there is also some enhancement with regards to the SIM toolkit. So SIM-based applications can be developed based on some of the enhancements. The 5G SIM can retrieve all the slicing information also from the device via a command which is called provide local information. And it is then, of course, also possible to develop and deploy interoperable Java card applets for specific purposes. Also, again, steering of roaming, monitoring of the quality of service within the network slice, or also location-based services based on that enhanced toolkit mechanisms. And again, a main benefit of doing such configuration in the 5G SIM is, of course, to avoid complex and device-dependent configurations that have to be done otherwise in a really highly fragmented 5G device ecosystem in a non-standardized way. Let's now jump into the improved mobile experience, trusted non-3GPP access. 3GPP release 16 supports multiple access technologies and also the handover between these access technologies. And that also includes so-called non-3GPP access technologies. And if we talk about non-3GPP, then we simply mean all the access technologies that are not part of a 3GPP specifications. And examples of them would be WiMAX, CDMA 2000, Wi-Fi, but also fixed networks. And supporting those accesses has, of course, several advantages. It allows providing services over non-3GPP technologies in areas and regions like a stadium or whatsoever, right, where either the network capacity, but also where the coverage is a challenge in rural areas, for example. So in those cases, of course, it helps to significantly improve the user experience when they want to use the service and they can use a different non-3GPP access technology to get access to the service. For non-3GPP access, you can distinguish between trusted and untrusted access, and we will focus on the trusted now. The trusted non-3GPP access for this one, that's just simply a decision by the network operators to trust and to potentially also operate the access points on the network and to use credentials for the authentication to that network through those network accesses, which are derived from the security context of the network itself. So the authentication to trusted non-3GPP network is done using something which is called EAP 5G. which is a vendor specific and based on EAP aka prime. So if that is configured by the MNO, then it's deemed to be a trusted non-3GPP access. And how that all works is also part of Release 16 standardization. All other deployment scenarios, so where the MNOs do not trust or do not operate or do not use authentication credentials derived from the network, all those other scenarios are regarded as being untrusted. And how does now, again, the recommended 5G SIM help here? Well, actually 3GPP does not specify which non-3GPP technologies should be considered trusted or untrusted. As I said, that decision is only made by the network operator. And once the network operator has taken a decision, then of course he can leverage also the new services and the new files that are available on the 5G SIM to store the list of all the trusted non-3GPP serving network names and access points and things like that. So an access point who is then listed in that elementary file can be assumed to be a trusted one. And in addition to that, MNOs can also easily update the list of those access points on the 5G SIM using their OTA file update commands and mechanisms they have in place. And last but not least, this feature also enables a smooth handover between trusted non-3GPP and 3GPP network access. Oops, sorry, that was too quick. Okay, the next one is a quick one. Let me conclude actually the list of major new features with multi-device and multi-identity. This feature was actually introduced to address the growing demand for multiple identities that have to be enabled on a single device, which allows then different subscribers to call and message on the same device. And conversely, there is of course also a demand for sharing a single user identity across multiple devices. We all know that. And that is in particular beneficial as we see that global connectivity is increasing. And here, the 5G SIM is also introducing an elementary file that allows storing those multi-device and multi-identity configuration data. And by this, exactly the intended use cases are enabled. That means users are allowed to use different terminals and devices that are registered under the same public user identity, but it also enables a user to use any of those different identities in various devices. And that actually concludes the list of features. Many thanks for staying with me until now. To finish the webinar, I'd like you to remember a few key conclusions and takeaways from this. So first one is that a lot of information on this subject can be found on the TCA website, the paper itself, but also some other information on 5G subscriber, privacy, integrated SIM, everything can be found there. So please check it out. Then with this new Release 16 paper, we are explaining the benefits of the 5G SIM that go well beyond the initial release. And that initial release, I mentioned, that was focusing on the challenges that MNOs were facing when they were migrating to 5G. As we see a huge momentum now in the 5G standalone network deployments, we also think that MNOs and other stakeholders should really leverage the extensive capabilities of the recommended 5G SIM in order to actually unlock the full potential now of 5G networks and technologies, all the new features that have been introduced in Release 16. And last but not least, please do note that JavaCard is the technological foundation for actually realizing a powerful new 5G features that I've mentioned, such as enhanced subscriber privacy with the applets that could be developed there. It allows MNOs to define their own secure solutions and even allows managing those post-issuance. And it also enables the development and deployment of new value-added services that are leveraging the new features and files on the recommended 5G SIM. And with this, I would like to thank you very, very much for your attention and also for your interest in this webinar. I'm now open and happy to answer any question that you may have. Jean-Daniel, over to you.
Many thanks, Klaus, for this very interesting presentation. We will open the mic, but in the meantime, we have a question from Jensen Peng, who is asking if the sushi calculation is mandatory to deploy the 5G services.
Well, the sushi calculation, it's, I would say, somehow conditional. So network operators can still decide whether or not they are activating this feature in all their deployments. So it could, for instance, there are certain encryption schemes that have been standardized, and there is also something which is called null encryption. That means that in those deployment scenarios, the IMSI would still be transferred in clear text. That is also the case for some regulatory issues in some of the regions. But I would say that in general, subscriber privacy is something which is a top priority, at least in Europe, but also in other regions of the world, which really, maybe not from a standardization point of view, but from a regulatory point of view, would force to use that feature.
Okay, thank you. Is there any other question from the audience? Please feel free. In the meantime, I have one. Yes, please.
Olivier from Infineon. Thank you, Klaus, for this presentation. So it's clear to me that this 5G new features are bringing a lot to the mobile consumer industry. So I'm not talking about V2X. This is something I don't know. For encrypted SUKI, confidentiality, all those things. But for the IoT M2M, do you also see sufficient benefit brought by the 5G? I mean, new features that will somehow force the industry to use all of them, or do you see MNOs still using the old-fashioned SIM to connect to the 5G network?
So there are also some new features that have been introduced, not really only driven by 5G, but I would call it in general, which allow some efficient power management. So for instance, there is also a new command pair which has been introduced in release 15 with suspend and resume, which allows the device to suspend the secure element, the SIM, in the devices in order to save some power. So there are some features that have been introduced also to accommodate for IoT.
Okay, but for the SUKI, for encrypted IMSI, do you see it as a mainstream in the future for devices that are just static devices?
Yeah, I'm not sure I understood completely the question. You were somehow at least interrupted. But if you were asking whether SUKI calculation is also relevant for IoT, the answer is yes, right? So even if the identity is not maybe connected to a person, but connected to a device, the identity is still something which is privacy of privacy concern, I would call it, and therefore it's of course highly recommended to also use SUKI calculation and encryption also for IoT deployments and IoT use cases.
Perfect, thank you very much.
You're welcome. I can see there is another question on the chat.
Yes, from Abbas Slim in the chat. For existing cards, can we update to compatible 5G by creating necessary files mentioned and updating the necessary service in USD? Or is it necessary to have a USIM compatible 5G application?
Yeah. Well, if it was only related to modification to the file system, then yes, then it would be possible. But in fact, that's not the case, right? So, for instance, I've mentioned the SUKI calculation, but also other features. They do actually require some changes also to the operating system. So it's not possible to, let's say, update an existing deployed 4G SIM with a new operating system and just by updating the file system to make it 5G enabled. So you need to deploy. The answer is yes. You need to deploy new 5G capable SIMs, and here the recommendation is of course to go for a recommended 5G SIM release 16. Which is also backwards compatible, fully backwards compatible, and allows you, even if you have not yet deployed a 5G network, allows you to be already prepared for the time when you have deployed it.
So I have a question myself. You will describe several use cases, which are well beyond the traditional mobile network operators like Industry 4.0, private networks. Do you foresee in the Trusted Connectivity Alliance that you will have to expand your activity beyond the standardization body like 3GPP, ETSI, GSMI to other markets?
Yeah, that's a very good question. And yes, we will, or we are actually discussing in Trusted Connectivity Alliance heavily around this. And 5G private networks is for sure a topic which is of high priority for us. We, of course, first of all, would like to position the technologies that we are having there. And that may also include that we need to reach out to, let's say, other players than we have done in the past. Yeah, but this is something which is not yet fully defined, but we are looking into this heavily.
And to come back to the question of Olivier before for the IoT, the IoT, the massive IoT is a huge market in terms of number. Do you see the 5G SIM having a good share of it, or only the high-end devices?
That's a good question. So, I mean, in the massive IoT, we potentially also have different types of networks, like narrowband IoT networks and things like that. So, if they are not actually requiring 5G features, then of course you could also deploy, I would call them earlier releases or dedicated IoT SIMs for that particular purpose. But we also see many use cases that are maybe massive in the term of numbers of devices and that are not really narrowband. Where of course also the recommended 5G SIM and its new features will play a significant role. So it depends. Yes, I see there is a lot of potential in IoT also for a high-end 5G SIM, but of course it depends on the deployment and the use case and whether really a 5G network is present for the use case or not.
We have another question from Pranav Singh, which is SUPI the same as was used in CDMA 2000 EVDO CHAP authentication?
Oh, I don't know.
That's
to be
a very
honest.
technical one.
Yeah, I don't know. I need to get back to this question. Sorry, cannot answer that. I'm not familiar with that CDMA 2000 thing.
Okay, so we'll go back to you.
Maybe it is, but I really don't know. Sorry.
Okay. So we'll take note of the question and we'll get back to you. Another one from Abbas Slim. What if the sushi calculation is delegated to the device instead of the USIM and using a null scheme for authentication?
Yeah, if a null scheme for not for authentication, but for the encryption of the SUKI is used, then of course the SUKI is equivalent to the SUPI, which means it's not encrypted and it still can be eavesdropped by IMSI catchers, right? That's with regards to the null scheme question. If it is done within the device instead of the USIM, then of course, I mean, the benefit of doing that in the USIM in our opinion is that first of all the security related calculations, the encryption itself, the encryption parameters and everything doesn't need to leave the USIM and doesn't need to be transferred to the device. So it's within a trusted and potentially, if we talk about eSIM, also is handled within a security certified environment, which gives you some security advantages. On top of that, if you do it within the SIM compared to the device, I mean, we all know the SIM is there since many years. It's a proven and interoperable solution for many years, and of course, it's potentially not the same if you introduce a new feature like this in the device space, where you have multiple also Chinese players and others that are not familiar to do that, and you potentially face interoperability and user experience issues then later on. And there are also some regulatory aspects around this, which are related to who is actually liable and who is responsible in case something goes wrong, in case, for instance, the algorithm is hacked, or if there is a security leak in the device implementation. And whom to sue then, right? So is it then the device maker who is liable for that? Is it the MNO who is liable for that? Who is it? So all these questions are quite complicated if you split such a security sensitive feature into, let's say, some parts that are handled within the domain of one stakeholder and the other parts are handled within the domain of another stakeholder. So I would really like to recommend you, Abbas, to have a look at the subscriber privacy documents, and there is also a webinar that we have recorded on that subject to learn more about all the pros and cons. That's a good read.
Thank you. Do we have any other questions? We are getting to the end of the time slot. No, okay. So Klaus, once again, thanks a lot for this very interesting presentation. I remind you that you will have access to the recording through your email and the material a little bit later after the presentation. I think there is the same presentation this evening, and I suspect you will have the material link tomorrow. Thanks for attending, and stay tuned because we have a set of other interesting presentation in the coming weeks. Goodbye, everyone.
Yeah, thank you also from my side. Thank you very much, Sean and everyone for joining. Thank you. Bye-bye.